The produced fluids leave the Christmas tree and enter a surface flowline system, usually a 2 or 3 inch pipe, which may be on the seafloor for subsea completions or below or above ground at onshore installations. If the production facilities are shared by a group of wells, as is often the case, the flowline will probably connect to a header or production manifold. The header is an assembly of valves which allows each well to be shut in or to be diverted to a particular portion of the production facilities, say for testing. From the header, the commingled stream of production from several wells moves on through the system. Normally, a separator is the first piece of production processing equipment that the produced fluid stream encounters. Its purpose is to separate the gas and liquid phases. Separators are usually classified by physical shape. For example, we might have a spherical one, or a single horizontal one, or a double barrel horizontal one, or a vertical one. Each type is more appropriate for a specific application, and its size depends on the volume of produced fluids to be handled. A 3-phase separator divides the production into gas, oil, and water. A 2-phase separator divides the produced fluids into gas and liquid. Let's observe the operation of a typical vertical 2-phase separator. The oil, gas, and water mixture enters through an inlet on the side of the tank-shaped vessel. The fluid stream immediately strikes a metal plate, which diverts the flow around the inner surface of the cylindrical separator, imparting a centrifugal motion. This motion throws the liquid to the outer edge of the cylinder and allows the gas to remain near its center. The lighter gas, now separated, rises through the center of the vessel while the liquid falls. Often the separator includes a system of baffles which spread the liquid out as it drops to the bottom of the vessel. This allows any gas bubbles carried in the liquid to easily escape. The gas phase, which is directed to the upper portion of the vessel, is usually passed through a mist extractor to remove minute liquid droplets entrained in the gas. This one, for example, is made of knitted wire mesh. There are other methods used to perform the same operation.
We engineers know that a higher volume of ultimate oil recovery can be achieved if gas is removed from contact with the liquid as separation occurs. This means that a long series of separators, each operating at a slightly lower pressure and allowing for the removal of the liberated gas from each stage, will allow for the highest oil recovery in the storage tank. This type of continuous separation is not economically feasible. However, multi-stage separation with 2 or 3 separators can approach the optimal yield, and that's what we often see in practice.
The oil separated at one stage goes on to the next. The gas is removed at each stage and is referred to as high pressure, medium pressure, or low pressure gas, depending on the stage at which it is removed. Field production facilities will usually have a high-pressure gas system and a low-pressure gas system, the low-pressure system often being tapped for fuel or compressed to satisfy artificial lift needs.